Hi class, this example is to show you how can you change your background and foreground color in the console by using the SetTextColor procedure in Urbane32 library. In Urbane32 library, there are 16 different colors already defined. They can either be used for the foreground color or background color. You can see here they start from black equal to 1, blue, green, and also total they have 16 colors. So you can either specify by their value or by the keyword. Like the black, they already make that as a constant value. So in order to change your background color and the foreground color, you need to save the value in the AL register. So this AL register combined with the foreground color and the background color, the value. So before you call SetTextColor, they will have that. So we see here, did you remember in 1 byte, okay, if we have AL in 1 byte, AL is 1 byte, so that means you have 8 bits. So if we have the higher 4 bits and the lower 4 bits separate, so this lower 4 bit actually is the foreground color. Then your higher 4 bit we're using for the background color. So when you add together, they will have your combination for your foreground color and the background color. We see the code example. If I want you, if you want to display a string, yes, we need to use the right string to display that string. But before you call right string, also if you want, you can change the font color. For example, this one we want to do is let's have our font color is yellow. So this one is we call the foreground color. And the background color will be blue. So then in order to make the yellow and the blue and the background color, we will have our value in AL. Because actually for here, your foreground color and the background color you only need for 1 byte. So here they still do that is they want to override to make sure the EAX, the higher 3 bytes has nothing. Because SetTextColor, they're expecting to read the value from EAX. So even here for the yellow is the color and the blue we times 16, we just make them become using the higher 4 bit. But then combined together, we only need to have 1 byte for the information, but they save in EAX. So you always can use this way. You're using your value for the foreground color plus the background color times 16. So this times 16 actually like you shift 4 bit to the left. Okay, so then after you have that, you call SetTextColor. So the color will change. So now we have our offset prompt message saved in EDX. You write, you call write string. They will display the background color is blue and the foreground color is yellow. You can either do this way or this one is equivalent to this one. Okay, let me further explain what this means. Okay, so like we say here, your foreground color actually is 0 to 16, or 0 to 15 because we only have 16 color. So then here you see, since you have 0 to 15, 0 to 15 is what? It's 0 to 15 is kind of like the hash value, right? Hash value is from 0 to F, that's 0 to 15. So each hex value you need 4 bits in binary. So here is for the foreground color. Since foreground color only need to have 4 bits, the same thing for the background color. Remember, we only have 16 colors as well. So that's why I need another 4 bits in binary. So each byte, that's a bit. right? So that's why here you see you have 0, 0, 0, 0 on this 1 byte. So actually they make the higher 4-bit is your background color value. Okay, so higher 4-bit. Then the lower 4-bit is your foreground color. Yeah, so that's how they will save in only 1 byte value. So that's why you see here yellow is foreground. So in order to add this one, because you are doing the addition, okay, so that's why the background color need to times 16. What mean times 16? Times 16 mean you have the value original like this, right? If you move 4-bit to the left, your value increase by 2 to the 4th power. Shift to the right, shift to the left. For 4-bit, the value multiply by 2 to the 4th power. 2 to the 4th power is what? Yeah, 16. Yeah, where's my font? Okay, I don't have this in my. Okay, so your 2 to the 4th power is 16. Okay, so that's why here, in order to get the combination, this one is earlier we show you because we know the addition. So you need to have your background color times 16. Or this one is we will talk about in chapter 6. Chapter 6, we can move the bit, we can manipulate each bit in a byte. So here they talk about SHL. SHL actually means shift to the left for 4 bits. Okay, so they are equivalent to each other. So this one is our set color example. Every time you want to set the color, you do 1 time. So later you can change it to another color.